60 over 180 reduces down to, was that 0? 25 over 18? That's it, right? 25 over 18 pi. So that's what it is in radians. All good. Okay, next up, draw me an angle of negative 2 pi over 3 radians. I don't know how to do that. I only know how to draw an angle if it's in what? Degrees. So that's what I'm asking you to do here first. Go ahead, change it into degrees now. So different part of your formula sheet. Look for where it says degrees, or sorry, radians to degrees. Radians to degrees. What's your conversion now? Multiply by 180 over pi. Pi's cancel each other out. That's why the pi's on the bottom. When you convert radians to degrees, and this will be negative, Cooper, 120. All right. Now I'm going to ask you to graph it. So no matter if you were here yesterday or not, we should be able to know how to graph negative 120. Unless you weren't here on Tuesday, but. What quadrant am I in? Let's go. What quadrant am I in? Oh, watch this. This is going to be good today. 4. Who's got 4? Hi, Ethan. What quadrant is negative 120 in? It is? Yes, it is. Nice job. Closer to negative 90 or closer to 180? Negative 90. So here we go. Which way should my rotation arrow go? Clockwise? What is that? What is this? Charades? Clockwise or counterclockwise? Clockwise, yes. Nice job. So there's negative 120. Anybody issues yet? Looking good? Okay, now find the reference angle for negative 120. Find the reference angle. Do we know where it's located? Right here. Terminal and which one? Should I highlight the y or the x-axis? X-axis. So basically, I'm asking you, can you find that angle right there? That's my reference angle. You can give it to me in degrees. That's fine. We'll change it. What is that reference angle right there? Here we go. Let's roll. Number 7. What's that reference angle? Thank you, Patrick. That was nice of you. 10? 60. How'd you get it? There you go. Notice how Braden took the negatives off? That's fine. This is still 120 degrees. I'm just going in a different direction. And then it's 60, but it does say what? In radians. So let's convert. Let's convert it. Go to your chart. Here or not yesterday, go to your chart. Degrees to radians. Degrees to radians. What's the multiplying conversion? Pi over 180. Say it again. Leave the pi out of your calculator. Leave it out of there. Just reduce 60 over 180. And that reduces down to, what do you got there, Isabella? 1/3 pi. Anything? Last one. Take the negative 120. Get me a positive angle that's the same terminal side. Take your negative 120. Give me a positive angle now that has the same terminal side. That's what I'm looking for. Negative 120 is the same angle as what? Positive. What are you going to do to it? 13? What are you going to do to it? Vinny? Okay, here's what I need. I got negative 120 from problem number 2, right? I want to make it positive now. Like I want it, what positive angle also shares that same terminal side? Add 360 to it. So an angle of what would share the same terminal side there? 240. And I'm sorry again, guys. I just want to drive the point home in radians now. Convert it. Convert 240 because I want the final answer in radians. So one last time, multiply it by pi over 180. Keep the pi out of your calculator. Just let me know what 240 over 180 reduces down to. Four thirds. So there's an angle that shares the same terminal side. Okay, there's a big last 3 days right there for you. Last 3 days. Any questions from you guys? Not bad, because today is going to take me about 10 minutes, and then you get the rest of the time for any assignment you want to work on, right? Which makes me happy because I hate standing up here the whole time. All right, here we go. We're still going to deal with radiance today, just in a different fashion. All right. You guys that were here yesterday, I told you how a radian was formed. One radian is formed, I'm just going to abbreviate it, RAD, all right? Anybody remember how the radian was formed from yesterday? You guys that were here? When the radius length matches what? When the radius length matches the arc length, yes. If the radius length and the arc length are the same, that's how an angle of 1 radian is formed. All right? So if they're both 10, 1 radian. If they're both 12 inches, 1 radian is formed. All right? So when the radius and the arc length are both the same measure, 1 radian is formed. All right, so can you do this quick example here for me? I got a radius of 4 units. So let me draw that in real quick with my beautiful circle here. I got a radius of 4 and an arc length of 8. How many radians did I just form? Don't yell anything out. Remember how 1 radian is formed when these are the same length. Right back there. All right, when they're the same length. So now if I have a radius of 4 and an arc length of 8, how many radians did I form? Go ahead. How many do you think? 2. Everyone agrees? 2 radians were formed. Perfect. 2 radians, because the arc length was double the radius. Perfect. Nice job. Tells me we're picking it up a little bit. Now, here's what's going to happen today, though. They're not going to be nice and easy as this one's double the other one. Okay, but they are going to have some type of relationship, so I need a formula. And that formula, sorry, Brian, is not on here. Okay, this is something you're going to be responsible for, but it is a very easy formula to remember. It starts out with theta, which we talked about, I think yesterday, maybe the day before. That's an angle measure. That's my angle measure. It is equal to, and you guys are going to finish this for me now. Remember, what was my angle measurement here? 2, right? How did you guys get 2? What did you do with the 8 and the 4 to get 2? You divided 8 and 4, right? What was the 8? That was my arc length, right? Arc length, we're going to refer to as S. So we took the arc length S, and again, I have no idea why it's called S mathematically and not A. No idea. You took the arc length and divided it by what to get 2 radians on this problem? The radius length, which we're going to call, hey, R. Go figure. So if you ever want to find the angle measure, you take the arc length and divide by the radius length to find out how many radians. That's what you guys just did for me, right? We just put it into a formula now. Okay. Where's your boy here? I saw him today. Oh, that's nice. Conveniently during 6th period. Okay. College, let's be real. All right. What, too harsh? Too harsh? Yeah, it's on the microphone too, so it's going online, so it's there. All right? I don't care. Tell them. Okay? All right. A circle has a radius 1.7 inches. Here's how I like to do these. What value is this going to be in my formula? Theta, r, or s? A radius has a length of 1.7 inches. What value is that going to get plugged in for? R, good. Find the length of the arc. So what am I going to find the length of? S, with a central angle whose measure is 2 radians. Where am I going to plug the 2 in for? That's my radians, theta. So here we go. Theta equals S over R. So theta, you told me, was 2 radians, so I plug in 2. S is the arc length. That's what I'm looking for. R is 1.7 radius length. I just need to know how you guys are going to solve these today. How are you going to solve them today? Because these could be flipped, and you could solve for R instead. How do you want to do it? What do you got for me? You're darn right you would. Cross multiply. S equals 2 times 1.7, 3.4. What are we working in here? Inches? Yeah, if I got 2 as my radian, so that must have been double the radius. So we good on that? Questions? Because now how we do it in math, we got to bring it back to real life. So why don't we just go to the clock right now? Real life, yeah. So you guys can go home and do this and impress everybody. Determine the number of radians the minute hand of a clock passes through. Okay, so we're determining the number of radians. So what are we solving for here? Out of those 3, we're solving for? Determine the number of radians. So that's radians is always my angle. So I'm determining what theta is here. Keep going. Passes through if it has the minute hand has a length of 5 inches. What's the 5 represent? Is that my radius length or is that my arc length? Radius length, yep. And the tip of the minute hand travels a total distance of 13 inches. That's going to be my arc length, S. Yep. So theta, that's what we're solving for, equals 13 over 5. $2.6. What is this? 2.6 what? Radians. This is always in radians. Okay, this always produces radians. Okay, 2.6 radians. Is it okay that doesn't have a pi with it? Yeah, radians can come without pi. It's fine. Don't add one in, please. Oh, back to our boy, the pendulum. Remember that? The clock? I showed you the photos because some of you didn't know what the heck a pendulum was. All right. Swings through an angle of 0.55 radians. Where are you going to plug that 0.55 in for? There's my angle. What distance does the tip travel? What are you solving for then? What distance the tip travels? That's my what value? S value, my arc length. It has a length of 8 feet. That'll be plugged in for? What's it going to be plugged in for? 8's going to be plugged in for 8. What is it? All right. Never mind. You guys didn't fall into it anyway. I was hoping to get everyone to go R, 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 and then I'd ask if we had pirates in the room, but it's fine. Forget it. It's fine. Never mind. Thanks for participating. Yep, I got a bunch. Don't worry. Here all day. So 0.55 theta equals S, which you guys told me I'm solving for, over R, which is 8. $4.4, what are we working, feet? So it travels 4.4 feet. Okay, those weren't that bad, right? One slight adjustment now when we get to number 4. One slight adjustment. Okay, still on the old pendulum because we can't get any more realistic than that. Swings an angle of 30 degrees. All right, what's the 30 going to be then in this case? That's my theta value. Okay, let's all stop right there, please. Everybody stop for me 1 second. Go back to the first page of the notes today, please. And we have to realize that when using this formula, theta has to be in radians. You can never plug a degree measure in for theta equals S over R. Theta must always be in radians. So any suggestions what I should do to that 30 degrees before I start? Because I can't plug in 30 degrees for theta. It's got to be in radians. Do we have a way to convert it into radians? Yes, we do. Let's go. Multiply it by, let's do this. What's the conversion? 5? Nobody has 5? Don't all talk at once. I'm sure it's somebody who was absent, right? And yep. How about 1? We definitely got a 1 here. Thanks. Look, if people who weren't here yesterday, they're like, why didn't Alex answer that question? Rattled right now. People who weren't here yesterday have no idea what happened yesterday. Keep the pi out of your calculator. Reduce it for me. 30 degrees is the same as 1 pi over 6 or 1/6 pi, however you want to roll over there, Megan. All right. You guys don't understand that one either. So that's what I'm going to plug in for theta. Let's keep reading. The tip of the pendulum travels a length of 4 pi inches. So what's the 4 pi going to go in for? That's my S. Find the length of the pendulum, R. So ready? Pi over 6 theta equals S 4 pi over R. You can cross multiply like Cooper suggested at the beginning. Ready? Pi times R equals 6 times 4 pi. 24 pi. Or multiply it on your calculator. Whatever you prefer, doesn't matter. What are you going to divide both sides by now? Pi. And what happens when I do that? See ya. They're gone. So my radius length, the length of the pendulum, is 24 inches. Questions? One more and that's it. I love it. Love it. Steering wheel of a monster truck. Here we go. Get her done. Let's go, guys. Here we go. Sorry if I offended anybody. 11 inches. 11 inches, radius of 11. So we already know where this is going. In for R. Everybody ever been to a monster truck rally? Because they don't sound fun. I've never been there, but it just looks like I've seen pictures, just people wearing the big earphones. So how can it be? There's like a family tradition there. Bring little Vinny to the monster trucks. Now, did you ever get to go in one? No? Okay. All right. A lot of dirt. A lot of dirt flying around. Did you ever get hit with the dirt? No? Okay, that's the way to go. Do people actually like bring trash bags and stuff to shield themselves from the dirt? Okay. But it was loud? Yeah. Okay. All right. All right. I only had one other person in period 3 that went to a monster truck rally. And they had never been in a monster truck either, so still waiting. Anybody else ever been in one, but maybe not have gone to a rally? Okay, just asking. All right, let's get going. Let's finish this one. Sorry for the delay. So I have R, and how far does a point on the steering wheel travel? So what am I asking you guys to look for? How far a point on the steering wheel travels? S. Yeah, I'm looking for S here. But here's the problem. What is not also here? Theta. I don't know the angle, but I think you guys can help me find it. What's the other key piece of information here? The wheel's going to make 4/5 of a rotation. So if I take this wheel, rotate it all the way around, how many degrees did it just go? 360. But it's only going to go 4/5 though. So what do you suggest I do with that 360 degrees in one rotation and the 4/5? Well, just multiply it with 4/5. If you're going to go 4/5 of 360 degrees, how many degrees are you going total? So this wheel's going 288 degrees. Let's see how much we've learned today. Can you plug that in for theta? No, it's got to be in radians. It's got to be in radians. So yes, we still need to convert. Multiply it by pi over 180. Reduce. What was it? 5 or 3/8? Or 8 over 5? Okay. Got me there. So that's how many degrees it rotates as radians. Can you finish the problem now for me? Oh, shoot. So theta, 8 pi over 5. There's my theta. S, you guys told me we're solving for, how far the steering wheel goes, over how long the radius is, 11 inches. (5s) equals 8 pi times 11, and then you're going to divide all that by 5. And there are rounding directions. Take a look. There are rounding directions here. Good to have you here, Matt. We're just about to finish the last problem. Thanks. Okay. All right there, Mr. Confident. Yep. Mm-hmm. What school were you just visiting? Oneana. Oh, okay. Good luck. Good luck too. Mm-hmm. SUNY party. That's where you went to. Okay. All right. And nearest 10th, this ended up being what do you got, Lucas? Save us. 55 point. I haven't even said anything. Just read. What are the rounding directions? Okay, not hundredth. So you want to take that 0.29 and make it point. Okay. Oh, I know. Thank you. Well, you sat there all confident, like you're just happy I was finally going to be done talking. Questions at all? Because you guys have the rest of the time now to get going. Matt, I'm sure you could pick it up. I don't think you need to listen to the video. All right, but that's up to you. All right, go ahead. Get after it, guys. Let's go. Books are over there if you need them. All of it's out of the book. If you want to try some of the other assignment, go right ahead.